Hi everyone, welcome to this new video, and in this video we are going to do a benchmarking on the Basu network. So for this demonstration I am going to use Hyperledger Caliper as the benchmarking tool, and we will be going to first set up a Basu network and then we will be doing a benchmarking on that network. So we will be setting up a 4-node Basu network and we will be performing a benchmarking on the top of that network. So what I have done already is I am in this Basu benchmarking directory, and what I'll do is I'll first show you what tools are required. So I have already installed the Docker Compose in my machine, and I have also installed the Docker as well, and I have also installed the Node.js uh, version. Let me see what's my Node version. Okay, let me install the Node.js first. So for that I'll use the NVM and I'll be using the Node.js version 16 for this. Okay, so let's run the installation script, and this will download the installation script. And now I can basically just exit out from this terminal, and let me open the new terminal and let's install the Node version 16. So by the time Node.js version is getting installed, yeah, it's installed. Now we can clone that quorum repository from where we can start the Basu network. So for what I'll do, I'll just run this command npx quorum quick start. I hope I wrote it correct, and let's try to run this. So it will ask us which type of network you want to create. So in our case, we will be doing our Basu benchmarking. So we'll be creating a Basu network. So I'll press 1 for Basu network, and I don't need the private transaction support. So I'll do no, and this I'll keep as default, which is low key. The default value is 1. I don't need block scout, which is a blockchain explorer. Skip this and I'll hit enter. Now the repository is here, and you can see we have the repository here in all those files. So one more thing that we have to do is we have to go to this config file, and inside this there is a Basu folder, and here if you go to this config.toml file, here we will be adding one more attribute so that we don't get any errors when we are sending up the transaction. So with newer version of Basu, you cannot send a lot of transaction from a single account for during a specific time, but with the help of that flag you can send as many transactions as you want, because we will be using we are benchmarking the network, so we'll be sending up a lot of transaction to see the performance of the network. So let's add that flag here, and the flag is transaction pool limit by account percentage. I set it to 1, and now I can run my Basu network. So what I'll do, just go inside this quorum test network, and you have to run the script, which is run.sh. This will download the images and this will start the Basu network for you. And again, this is a 4-node validator network where we have 4 validator node, and we will be benchmarking against those network. Okay, so the network is up and running, and we can just verify it using Docker PS just to see if all the containers are running and not. And I see that all the containers are running, and we can see that we have these validator nodes as well. And validator nodes, the RPC endpoints is exposed on 21004. Okay, so now what we have to do is we will be basically uh, cloning up one more repository, which is the Caliper benchmarking repository, which has certain sample benchmarks available, and we will be going to use benchmarks from that particular repository. So what I'll do is I'll just quickly move out of this directory, and do I'll just clone that repository. So this is the repository that I was talking about. Like, this is the repository Caliper benchmark, and let's clone this repository. And after cloning up this repository, we will be setting up the configuration file, and like how the caliper can connect to the Besu network, and what is the smart contract that it has to invoke, and then we'll also see the benchmarking files. So now the repository is cloned. Now I can go inside this repository, which is caliper benchmark, and let's first install the caliper itself. So I'm going to install the latest version of Caliper as of now, which is version 0.5.0. And after this, we will be going to create that file, which is the config.json, which will have the details how to connect to the Basu network and what addresses it has to use and what is the smart contract API and all those things. Okay, Caliper has been installed. Now we can go ahead and create that file. So what I'll do is I'll create that file at the root level itself, and I'll call this file as config.json, and I'll just put the required set of configuration here. So let's understand the configuration. So uh, so here you have to set the blockchain as Ethereum, because Besu is again an Ethereum client, and then here we'll give the information regarding our network. So here I'm giving the URL, and this is the WebSocket URL. So remember, this needs to be the WebSocket URL because right now Caliper doesn't support the RPC endpoints. Then you have to give the contract deployer address if you are deploying up the contract with the help of this script or with the help of Caliper. And then you can also give the private key of that public account. Then here you have to give the from address, from seed key, which is the private key. Then you can also see the private key I have mentioned here. And in this contract section, we are basically giving up the contract which we want to called out as the part of our benchmarking, and this is the ABI for that, basically for that contract. So what I'll do is we have to provide the address here, because if you provide the path here, so what will happen is Besu or this Caliper will try to install this chain code, but this is not what I want. I want to install the chain code by myself and just provide the address here. So what I'll do is I'll just remove this, and I'll give address as a key here. And what I'll do is I'll first install the smart contract, and then I'll basically give the address here. So what I'll do is I just need to get the IP address of my machine so that I can install this smart contract through Remix ID or MetaMask. Okay, so this is my machine IP. I'll copy this, and so now what I'll do, I'll just go to my browser and I'll install the MetaMask. So here if I just try to see the extension, I'll just simply create a new wallet here. Okay, I'll skip this part. And now what I have to do, I'll just go here and I'll go to settings. Probably it's here. Or I can directly go here and click on add network, and I'll add a network, and I'll call this as Besu benchmarking network. Benchmarking network. And here you have to give the URL, so I'll give the HTTP URL and my IP address, and that RPC service was running on. Let's verify on which port RPC service was running on. So if I do docker ps, we can see yeah, so we can give these endpoints. So I'll give this as the port number, which is 21002. Just copy this, put it here, 21002, and I'll give the chain ID as 1337 because the Genesis file that is used to create this network was having the chain ID as 1377. Give this currency symbol as ETH, and I can just click on save. And I'll now switch to my Besu benchmarking network. Now this is done. Now the next step that I have to do, I've just opened the Remix ID so that I can install the chain code. And the chain code that I'm going to install is present in this folder structure itself. So I think that is here in SRC Ethereum, this simple.sol. Let's copy this and I'll go to Remix. And what I'll do, I'll just use that smart contract here, and I'll use it to deploy. So I'll click on this, just replace the content, and let's see if this compiles or not. Okay, it compiled successfully. Now I can deploy it, and before deploying, I'll just change this to injected provider MetaMask because this transaction I want to send it via MetaMask so that it can reach to my local blockchain network. And I have to first connect my account. Now I can simply go and click on this deploy button. So it will ask me to sign the transaction. Just confirm the transaction, and the transaction has been confirmed successfully, and now I can copy the smart contract address. Now what we have to do here in the config.json, there is this address field. Just put the smart contract address, and this is the gas section. So we are going to call certain function from the smart contract. Let's go and see the smart contract once again. So you can see this has one function which is open function, then there is a query function, and then there is a transfer function. And here we are specifying the amount of gas that we want to give while we execute this function. And this is the ABI for the smart contract. So whenever you will compile the smart contract, you can easily get the ABI and you can put it here. Now, the next thing that we have to understand is like how to run the benchmarking. So, and before doing that, let's see one more configuration file where we define the benchmarking parameters, like how many transactions it should send and what should be the rate control, whether it is a fixed or it's a linear rate. So those things we define in that configuration file. So that file is present inside this benchmark folder, and then scenarios, simple, and you can see this config dot YAML file which has the details like how to send the transaction or what should be the transaction and how the transaction should be sent and what all parameters you are sending along with the transaction. So this is here we have defined the structure, or you can see some parameters that we are defining that we want to send or use in this YAML file. Then the name of the test is simple. Again, there is some description and the number of workers that we want to have. So for now, I'll just increase the worker to 4. So you can see this round section. It's an array, and here you can see the label is open, and you can give the any label you wish to have. But here we are giving the function name as the label, and then you can see the transaction, the number of transactions that you want to send, and this is coming from number of account which is defined here. So we are going to send 1000 transactions, and you can see this rate control. So this is defined here. We are defining the rate controller, basically how the transaction should be sent. So I'll share you a link from where you can read more about the types of rate that we have in the Caliper. So for now we are just using the fixed rate, and the number of TPS that will be sent is 50. So we'll be sending a batch of 50 transactions every second. Now this is the workload section, and what is defined here is the module. So which module will be executed when this particular round will be executed. So when this round will be executed, we are going to use this module, and this module will have the definition like how to invoke that particular smart contract function, and this is the arguments that we are going to pass to this module. So you can see that this is coming from simple args, and simple args is defined here, which means that we are going to pass all these parameters to this function or to this file. Let's see this file, which is open.js. So if you go here, you will be able to see all those transactions that are, all those parameters that are sent here. So you can see that this is the create simple state, and you can see, the parameters that are, captured here in this constructor. And then you can see we are basically simply, using this uh, get open account arguments function, which is going to give us all the arguments, and then we are passing those arguments to this open function. And this is the name of the function which is there in the smart contract. Now let's go back here, and similarly we have defined, functions, or even the calls for different scenarios or different functions. So there was one query function in the smart contract. So we are again defining up a workload for that query function. We want to measure like how many transactions per second, or what's the latency for this particular smart contract function. Then there is one more function, which is a transfer function, which has all these details like the rate control type is fixed, and the TPS that we are going to send is 5. And this is the module which is used to evaluate this transfer function. Now let's go to the terminal, and from here we can, run that benchmarking test, and let's see the outcome here. So let's put this command here, and in this command what we are trying to do, so we are basically binding up first the Basu system under test, and then the second command that we are running is basically the npx caliper launch. We are giving the benchmark configuration file, which is, this config.yaml file that we just saw. And the second thing that we are passing is basically the config.json, which defines like how to reach out to or how to connect to your Basu network. Then we are giving the, system under test, so we are running this for Basu. And this is one of the flag that I am using here, which is the, caliper flow skip install, which means that it is not going to install the chain code, rather it is going to use the information or the chain code address that I have given in that config.json file to install or to do the transactions. So now it's first setting up the required dependencies, and then it will start running up the benchmarking. So now let's run this command, the second command which was for benchmarking. Let's run this. Okay, so we can see here that let me just collapse this, and let me see if I can zoom in. So here you can see that test has been already started, and it has already started up sending the transaction. So we defined the workers as 4, which means that there are 4 threads constantly sending up the transactions. You can see worker 0, then you have worker 1, then there is worker 2, and then there is a worker 3. And you can see that the total transactions that are, getting sent. So we have submitted these many transactions. These are the successful transactions at the particular moment, and then these were the unfinished transaction which was still under execution. And we got the result for one of the function, which was open, or the label that we have configured in this config.yaml file. You can see that the number of transactions that we sent were 1000, and the failed number of failed transactions 0. The send rate is 50 because we have configured that the TPS, or at what rate the transaction should be sent, is 50. The latency that we can see, the maximum latency that we see is 7 seconds, 7.8 seconds. This is the minimum latency. This is the average latency, and this is the TPS, or the throughput, like how many transactions we are able to execute within a second. So we are able to execute 44.5 transactions within a second. Okay, now let's go down, and we will be able to see the same kind of a table for another function, which was query in the smart contract. And here also we send the 1000 transaction. The number of transactions that got failed was 0, and the send rate is 100 in this case. And if you see the throughput is also 100, which means that all the 100 transactions got executed in just seconds. So which means that this network is capable of, executing this similar kind of a transaction at a 100 TPS rate. Let's go down. So there was one more function, which was the transfer, and the success rate that we see here is, or the successful transaction that we see here is 48. And we can also see the send rate. So 5.5 transaction was sent on an average to the smart contract, and we can see the throughput. The throughput was 4 in this case, which means that we are only able to execute 4 transactions at that particular moment of time. Now we have the consolidated view as well. So you can see this is the consolidated view. where it's giving us the report of all the functions that it has executed along with their TPSs. Let's do one thing. Let's run this function. Let's run this benchmarking in, and I'll try to tweak some parameters, and let's see if we see any increase or enhancement in the performance. So what I'll do here is I see that the number of transactions that we sent for transfer was less. So what I'll do, I'll send 1,000 transactions, and let's see, or maybe not 1,000, but let's say I send 500 transactions, and let's see how it happens. So I'll quickly go here. I'll go to terminal. I'll clear this out, and let's run this benchmarking test again. So it's sending up the transaction for that open for open function, and let's wait for it to get completed, and then by the end of this execution we will be able to get a complete report whether the TPS got improved or not. So one more thing, meanwhile this is running, I just want to show you the different type of rate controllers that we have, and that those rate controllers you can use. Uh, you can define those rate controllers here, and you can do the benchmarking as per your uh, uh, expectation or with the behavior that you want to drive. So I'll just quickly jump into my browser, and from there let's try to see the different type of rate controllers that we have. So here I'm in the official website of Caliper, and here you can see that there is a section inside the reference which is rate controller, and when you go to this section you can see the different type of rate controller that we have. And right now we are using the fixed rate controller, which was sending up the transaction at a fixed amount of TPS. Then we have different kind of rate controllers here, so you can use them as per your requirement. So there is this fixed feedback rate, which basically will see if the transaction is getting filled, then it will reduce the load onto the execution. So you can refer this documentation to read or to understand more about the different type of rate control that are there in the Caliper. So for now, let's go here and let's see what's the outcome of this execution. Okay, so since it's taking a lot of time to get this execution done, so I'll stop this video here, and hope you get an idea like how to do the benchmarking on the Besu network, how you can define the configuration, like how to connect to your Besu nodes, and after that you will be defining this config.yaml file, which is the benchmarking configuration, and this will talk about like how many workers you want to have, how many transactions you want to send, and how those transactions should be sent to your smart contract. So all those properties of or functionalities you will define in this file, and you will also creating up this modules where you will be defining up the function that you want to execute and along with their parameters. You will be also installing our chain code. So in my case, I installed the chain code by myself, and I gave the address here of the chain code, and then I was able to do the benchmarking because I had the contract already deployed, and all I have to do was just to send some transaction to the smart contract. So that's all for now. Hope you enjoyed this video, and if you did like this video, then please give a thumbs up and subscribe to the channel, and I'll see you in the next one.